Okay, so welcome back. Now we ended at variables. So this is where we are going to continue from. Now, one of the core concepts in programming is the concept of variables. Now, variables, they are simply placeholders for values in memory. A variable is a space in memory where data is stored. Okay, that is about variable. Now, we all, one way or the other, are familiar with these variables that we are talking about. And so if from the previous lectures, if you have installed the code blocks, the setup or the application I walked you through, I would like you to open it so we look at the practicality of variables. Okay, so let me open my code blocks. Okay, so when you open your code blocks application, this is going to be the interface. Now we have recent project and then recent files. These are the project recently I've been working on, and down here they are the files I opened recently. Okay, now I think you, if it's your first time, you're not going to see either of these ones. You don't see the recent project. You will not also see the files. So what we'll do is let's just use the create new project option. You use the existing project when already you have some there and you want to open. So click on create new project. When you click on it, for now, choose console application. We are learning the concept of programming, so we are going to deal with the console. So just double click on the console and then choose C++. Over here, it's very important. Now you need to select the folder you want your project to be created inside. Over here, this is the path I have. Now you have to take note that if you don't set the folder to create the project in, it will never work. Okay, so what you do is you just use the three dots against the text box and you select the particular folder you want your project to be stored inside. So let's say if I want to have my folders stored in my project stored in my website, you just click on it once and then you choose what? Select folder. So choose any folder of your choice and click select folder and let's continue. So I'll leave mine at the default or the selected project folder I have, and then the name of the project, let's make it variables. Okay, so variables. As for this one, don't touch them, just leave them. The most important thing is just set the folder you want to create your project in and then the title you want to give to the project. When everything is fine, you just go to next and then you click on finish. That is it. So quick one, let me just do a walkthrough to this code blocks ID. Okay, so when you create your project, this is what you are going to see. You are just going to see a blank screen like what I'm seeing here or what we are seeing together. Okay, now the project is created and the files to work with, they are all available, but we need to trigger a particular functionality, or we need to just display the hidden files. Now to do that, you just go to view. So if you see view up there, just click on it and then you can see we have what? Manager. So this is where we can be able to have access to the files and then the folders of our project. So I'll just click on manager. You can see the moment I clicked on, I have a sidebar opened. Now in this sidebar we have so many tabs. We have the symbols, we have the resources and the others. Just make sure that always you activate the project tab. When the project tab is active, it's going to show you the name of your project and of course the files the project depends on. Okay, so I want you to expand the sources, and then when you expand the sources, you double click on the main.cpp file. So this is the main.cpp file. this is what we are going to use for our C++ codings. Okay, now quick one. It can happen that sometimes, maybe for some reason, the sidebar will go away. So if you want to have it back, like I showed you, you go to view and then you click on what? Manager. So after you click on manager, you realize it will what? It will show. Okay, so that is it. Let me reduce the magnifier and then I'll zoom it in. So for the sake of the tutorials, I'll close the manager. But in case yours is closed, I hope you know how you can bring it back. Okay, now this is C++ program or project setup. Whenever you create your project using the code blocks, this is going to be the initial setup or the project structure you are going to have. Okay, the IOStream or F #include IOStream, it means the input output stream. This one will allow us to take input and then also what? Display something. Okay, now the focus is not really about C++, but it's just to show you around. Okay, when we finish with programming methods, the next thing that will be on the line is what? C++. So for now, permit me to just go straight to the point and then what? Start with whatever we have to do. And I want you to understand that for now, you see we have int and then main. So this int main is the entry point to the application. What do we mean? We are trying to say that all the codings that we will do will have to be inside the int main. Okay, so when I click on the if I click here, you can see the highlighting is from this side all the way to the closing. So this is telling you that it's a body. Okay, so your coding will have to be inside the body of the int main, and at the same time you have to make sure you don't write the code beneath the what? The return O. The return O or return 0 is always supposed to be the last thing. The main reason why this is it is because when you run the program, the compiler will start the execution from top and then execute it line by line like this. Okay, so as the execution is going on, the moment the compiler sees return O, that is like a full stop for the compiler. It will not stop, it will stop compiling. It will not proceed again. So always you make sure your code will be within the block of the int main and at the same time above the return what? Return keyword. So quick one, let me just show you why I'm saying this. Now I'll move it down a bit like this. So we can see out and then what? Hello world. So this out and then hello world is a way of displaying information. Okay, so I'll run the program, and to run the program I just use build and then what? Run. I click on this one and then you can see the command prompt is opened and I can hello world is now visible. Okay, so this is the structure. Out, you call this one we call it left shift. 2 arrows will come at the end. The 2 shift left shift will come and then also end L. This one is L, not 1. Okay, then your end L will come, that is end line. So the content you want to display will always be in between. Now make sure you put them in double quote. Okay, make sure they will always be in a double quote. If you remove the double quote from the content you want to display, when you run it, it will not work. You can see there's an error here. Okay, so that is something you need to keep in mind. The hello world or whatever you want to show to the user, it should be what? In a double quote like that. Okay, I think we can move on. So let me show you what I wanted to show you. You see, each time I run the program, hello world will be seen, right? Now, suppose I take the out away and then I place it beneath the return O. I told you that when the compiler sees the return O, that is like a full stop. It will not compile again. So now when we run the program, you can see we didn't see the hello world on the screen. That's because the out or the command that is displaying is below the int main. When the compiler got to this point too, it ended the execution. or it ended the compilation. So as a result, this is not seen. That is why I said always your code will have to be number one in the block of the int main, that is within the curly bracket, and number two, it has to be above the what? The return keyword. All right. So that is about, a simple structure walkthrough of what you are seeing here. For the hash include IOStream, for these ones, leave them. Always make sure they are there and don't clear them. Later on, at the appropriate time, we will look at all of them one by one. Okay, but permit me to move faster because the goal here is to look at variables. Okay, now in mathematics, we saw something like this: s is equal to 5, something like this. Okay, so meaning x is like a container and we are storing the value 5 in it. This is what we call variable in programming. Okay, now let me simply show you this. To create a variable in programming, it's very simple. You simply need what we call data type, identifier, and then value. Okay, this is the structure for creating a variable. You need a data type, identifier, and then what? A value. These things that you are seeing, they play important role. Okay, now for us to look at the data type and identifier and then the values, let's move on to the let's go to the slide. We'll talk more, look at it very well there. So variable is a placeholder for values in memory, and variable again is a space in memory where data is what? Where data is stored. Now one thing you need to understand is for variables, their goal is to store values. That is it. Their goal is to store values. So you can do something like a is equal to 20 and then b is equal to 70. Okay, so that means we have a variable. This is a, and the a is storing the value what? 20. That means wherever we see a is equivalent to what? 20. The same thing too is happening here. So suppose we have another one like c and we say that a plus b. What do you think their answer will be? Of course, it's going to be what? 20 plus 70, which I think will be 90. Okay, when you add the two, it's going to be 90. So this is all about variables in programming. Just creating, a container, and the container should store values. That is it. A, B, C are containers or names we have. And these ones are simply storing values. That is what is coming after the equal to sign. Okay. So the equal to is important. You take out the equal to, is wrong. You need to always make sure you have the what? The equal to there. So that is what you need to keep in mind. A container for storing values. Now inside the computer's memory, we know RAM, right? Whenever you launch an application or whenever you create your software, the variables are stored on a computer's RAM. That is the location for the variables. They are always stored in the computer's what? Memory or the RAM. The moment you power off your PC or you close the application, the variables will be away from, they will be taken off, they will be off. The RAM is highly volatile, right? So it doesn't store data permanently. When you run an application, the variables will be loaded onto the memory. When you close the application, then the information goes off. Okay, so that is about variable. Then we have identifier. Identifiers are the names we give to entities inside our programs. Names for variable, procedure, array, structure, union, and then others. So that is about identifiers. Now, if you look at what I have here, it's very simple. So A is an identifier. Are you with me? B is the identifier. Simply, the name you give to your variables, they are the identifiers. Okay, so that is about identifiers. The name you will see in order for you to what? Recognize that this is a variable. Now, over here you can see C is equated to what? A plus B. A is storing 20, right? So A is the identifier. We can make reference to the A to get 20. we can make reference to the B to get 70. So the A that we are making reference to, or the B we are making reference to, they are simply the what? The identifier, because it is that is giving us, access of having that value, getting access to the 20 and then 70 respectively. Okay, so that is that. I think time is really moving. Let's move on. And then we have another one we call data types. So if you check my formula here, you can see I have data type, identifier, and then what? Value. Okay, so let's look at data type. When we create variables, that is a space in memory, we need to be able to let the computer know the kind of data we are going to store. Data type therefore instructs the computer as to the exact amount of space to reserve to fit our desired data. Okay, so you can read what we have here, but then let me simply go straight. There are various kind of data out there, but then the most common ones that we will look at is integer, float, double, character, string, and then boolean. So these are the most common data types that we have in almost all the languages. We can have more than this, okay, but these are the ones that are common. They are known everywhere: integer, float, double, character, string, and then boolean. Okay, so let's look at what these ones are, then we will combine all of them together. So what is the integer data type? The integer data type, they are simply what? Positive and negative whole numbers. Float is positive and then negative fractional or decimal numbers. What about the double data type? This one too, it's just like the float, but it reserves more memory. We have the character data type. Character data type is for storing a single character. Okay. Then a string is a collection of what? Characters. This data type is responsible for storing collection of characters. And then boolean is simply true or false. Okay. So let me take my time and then take you through one by one. First of all, let's go back to the code editor. Okay. I simply showed you this approach, but to create an actual variable, this is not how we do it. Number one, we need to start with what? Data type. And then number two, we follow it with what we call the identifier. Okay, so let's say I want to store my age in the program. The first thing you need to think about is age. What kind of data type can we give to age? Okay, now I think for age, it's whole number. It's whole number. So for age, we can have 3.5. We can have 7.8. It's never allowed. Age are also supposed to be integers. So the data type for storing whole numbers is what? Int. Positive and negative whole numbers. So because we know age will fall within this, I will now need to let the computer know that this new variable that I'm coming to create, the kind of data is going to hold will be what? Integers. That is the first thing, the data type. So always know the kind of data you are going to store. Then you give it the appropriate data type. Now moving from there, we have the identifier. So with identifier, it's very simple. What name are you giving to this whole variable you are coming to create, so that it will be easily understood by others too as well? It makes sense for me to call it age, because this is simply representing what? Age. And then let me put my actual age there. So my age is simply 175, like this. I'm really old. Okay, so this is how we can create a variable. This is one variable we have created. Okay, this variable is representing my age. This is the data type, simply telling the computer the kind of data the whole variable here we have is going to store. And we have age. This is what we call the identifier. We can be able to refer to this variable using the what? The identifier age. And then finally, we have the equal to sign and then what? A value. These two they are important. So the equal to sign you are seeing here is, we call it assignment. Assignment. We are using the equal to for assigning 175 to the variable age. So that is it. What comes right after the equal to sign is what we call the value. This one is the value. is going to be stored in what? In age. Okay. So up to this point, if you have not subscriibed to the channel, kindly try and then subscribe to the channel, give your comment, your like. Let me know what you think about what we are doing now. Okay. All right. So we have the age created now. Let's see, after the age, I would like to also store my name. Okay, my name. So to create a variable for storing name, first of all, you need to think about this. Name. You see, name cannot be number. We can't use integer for name because integer can only store positive and negative whole numbers. And then we have float. So float too, it can store what? Positive and negative fractional, that is decimals. My name cannot be decimal. Okay, so I will not use any of the two. Let's look at the double. Like float, but reserves more memory. So that means the float and then the double, they are the same, just that in terms of size, the double is bigger. So meaning double is also used for storing decimals. Then we have character. Can we use character for storing name? So for character, single character, number, and a special character. So that means when we use a char or the character data type, it can store a single letter, a single character. It can't hold more than one. Well, let's go down here. String. So a collection of characters such as name of people, the name of people or places. So since I want to store my name, I think I can use what? The string data type. That is best for storing names of people, location, places, and the others. So I begin with the keyword string, and then the next one is identifier. Let me make it name is equal to John. Let me make it code with Ibra. That is the name. Okay. So wow, we have two variables here. The name variable has a data type called string. So the computer will understand that because we have string here, automatically is going to what? The variable is going to store series of characters. And one thing you can see here is with the string, I added double quote. Whenever you are storing a string variable, you need to add double quote. If you don't add double quote, it will not work. This is something you are not the one to change. It comes with the language. Okay. This is what they have defined or specified, that whenever you are creating a string variable, the value, put it in a double quote. If it is an integer or if it is any number type, just put it there. But if it is a string, double quote is supposed to be what? It's supposed to be there. That is that. Okay. So wow, now we have two variables. I have age, I have name. I want to also create one variable to represent my height. Okay. So height, let's go back to our dictionary to look through. We have integer, and integers can store just whole numbers. And you know, it's possible that for height it can be maybe 3.7. Decimals can be in height. Okay. So because decimals can be in height, we can either go with what? Float or double. So for this one, let me use float. If you use double too, it's correct. So let me use float. Float. Height is equal to my height, I think is 8.7. Okay, so 8.7, this is height. Okay, this is my height. Now don't go and then add the meters or the unit of measurement. If you have a float variable, it is strictly decimals. Don't go and then add any unit of measurement. That will not work. So you just have to make sure you put the number there, just the number. That is it. Apart from the number, you don't add any other thing again. Okay. Now in the future, we will look at the fact that whenever it's float, we need to add the letter F to it for the compiler to better treat it as a float. But for now, let's just use it straightforward. Later on, we will look at all these ones. Okay. So we have the height variable created, and that is how to create a variable height. Now let me create another one to represent my salary. Okay, my salary. So you know, when it's salary too, we can have decimals in it. So anything finance, money can have decimals. So for anything like that, my salary, I can use float. But you know what? Let's use double salary is equals to. So this is salary. Okay. The main reason why over here I use float and then over here I use double is whenever you see money, the size of money can be bigger. Okay. And then you see, fast for height, it can't be that huge. So always, this is the rule of the thumb. Whenever you are storing or creating variables to hold money, use double, because the size of the double is bigger. It can hold huge amount. Okay. And another thing is, whenever you are performing calculations with double, the outcome tends to be more accurate. So, you know, especially calculation around money, we want to make sure that we get the exact, result. So use double for your variables about money. Use double. If it is, normal thing like the height, the weight, anything normal, you can go with what? The float. Okay. But behind the scene, you just have to understand that these two data types, they are similar. They store decimals. Okay. Just that the float doesn't have huge size, and then the double, it does. Okay. All the variables, they do have sizes in byte. So that is it. Int like this is having a size of 4 byte. Float is having a size of 4 byte. Double is a times 2 of float. So double is having a size of what? 8 byte. Okay. So that is it. Now let me also create another variable to hold my gender as male. So gender, if with a gender that I want to have, if male is M, if it's female is F. So realize it's just a single character. And whenever it's a single character, we use the char data type. So you put char here, and then gender is equal to M. Okay. Now let me say this. You can see if you are using a string data type, your content should be in double quote. If you are using the char data type, your content is supposed to be in single quote. The value is supposed to be in what? Single quote. That is it. You can change them, you can mix them. This is how it's supposed to be done. That is what we call the syntax of C++. They have made the language to be like that. Okay, so we are just learning to follow what is already there. We are not coming up with our own rules for the language. Okay, string will have double quote, char will have a single quote, like that. Now let's go back to so far we've seen all this with the exception of what? Exception of the Boolean. Now the Boolean data type stores just two values, true or false. That is it. Okay, true or false. So let me create one variable, can vote. So can vote is equal to true, and the data type is bool. Now in C++, if it's Boolean, we just write the short form bool here, meaning it's what? A Boolean data type. Okay, so if it's Boolean, it can store just two values, true or what? False. Now later on, as we move on, we'll look at the importance of Boolean and how we can use the Boolean for a whole lot of stuff. But just understand that if you want to store true or false, you use Boolean. Now instances can be, maybe you are filling a form and you see a portion that asks you marital status, or maybe is married. So if the person is married, that is true. If the person is not married, it's what? False. Okay. It's a student, so it's student status. When filling a form and you see something like that, you can see true means what? You are a student, and if it's false, it means you are not a student. So throughout we'll be using Boolean a whole lot, but that is all about variables. To create a variable, you need a data type, the identifier, and then what? The value. Don't forget about the the equal to sign. This equal to sign is very important. This is what is doing the assignment. Okay. So over here, data type, identifier, and then value. Again, if it is a string, the value is supposed to be in double quote. We also have float. The float data type stores number, double to stores number, but they are specific to decimals. If you are aiming at storing integers, whole numbers, then you go with the int data type. We have the char. You only use the char when you want to store just a single character. If it is more than one character you want to store, then your friend is what? Strange. Then we have the Boolean data type. So Boolean is for storing true or false. True or false, just like that. Okay. So this is about variables and then what? Variable creation actually. Now the assignment I'm giving you is look for sizes for the above data types. Okay, so go and then look for sizes. What is the size of integer? What is the size of string? The size of float? All of them. Look for the sizes. Okay, and then when you finish, just do this: create variable for the following. So create for variable for to hold school name. So let me just make it like this: school name school fee. Then I think school total student. Then I think we also have to have school height. Let's just have that. We want to create the school height, the height of the school. Just put the height of the school there, and then school status. So this school status, let me just explain. Okay, we can have so many status, but this one, you see, we have some schools are for male. Okay, then I think let's make a school gender status. Okay, so this one, it's going to be seen like we will use it to see if the school is just for male or for female. So the gender status of the school, if it's male, then it means the school is for only male. If you make it female, it's for just females. Okay, so this is what I want you to do. Number one, just create look for the size for the above data types, and then when you finish, create variable for the following. The variable names are supposed to be as it is. Don't add a space. Do them the same way I have done it here. I will explain to you what this means and why we need to do it like this. Okay, so I want to thank you so much for the time you have spent with me here. Now I hope it wasn't wasted. So try also and then give us subscribe. Just let us have your subscription. Let's have your comment, your likes, and also your recommendations. Recommend the channel to your friends. Let them also come and then learn. Thank you so much. Bye bye. Okay, so the next thing I would like us to look at this moment is what we call the rules for naming variables. Rules for naming variables. So if I go down here, there is this is this topic. Rules for naming variables. So when giving names to your variables, we have some do's and then don'ts that we follow. And so if you look, for instance, the exercise I gave you, you can see we have school and then what? Name, all joined together. I didn't include space in. Okay, now this is one of the rules. So let me just clear everything and then we'll start all over again. Go back to the slide. Now it says what? Variable names should express what it would store. Now when giving names to your variable, they need to be meaningful. For instance, I want to create a variable to store a customer's name. Okay, let me create some couple of variables and then I'll show you, I'll let you choose the one you think is best. So since it's going to be name, we use the string customer. Let me just say customer name is equal to John, and then string name is equal to John. We also have string cn is equal to John. Now let's say you are not a programmer, but you've seen a code like this. Which of these three variables will be very easy for you to know that, okay, it's storing customer name? I think if you check the first one like this, it makes more sense because you don't need to even do extra thinking to know what this variable is all about. Now check the last one, cn. Maybe in your mind you want to store, you are making it customer name, you get it, but only you will understand. And if you are working in the field as a programmer too, you are not going to be yourself. There's a lot of people, a group of people you are going to work with. So you try to make your variable names more descriptive and meaningful. Try to express what you are storing in your variable names. Okay, I think the first one will do. This is more specific. This one too is like general. Okay, and then this one is very, very bad. So make sure you choose a name that will be what? That will be more descriptive. Okay, so that is about the point number one. Going to the point number two, it says should be simple and then what? Straightforward. So like that, your variable names are supposed to be simple and straightforward. They should be written together as let me see if I can. Okay, wow, I wanted to, wow, let me see. So they should be written together as one word if the name spans more than a word. Example, first name. Let me combine these ones together. And the naming conventions like Pascal and camel case are accepted. So these two, they are very, very important. Now what they are trying to say is for your variable names, they are supposed to be written as one word. Yes, they are supposed to be written as one word. Now if you check customer and then name, you know it's two things here. We have the customer and then we have the what? We have the name. It would have been easy for us to do something like this. But in giving names to your variables, if you add a space, it's totally wrong. We don't do this. You try as much as possible to join them together. Let me try and then run the program and see. So you can see we have the red indicator here telling us that there's an issue, something wrong with this line. Okay. So you don't want to do this. You need to what? Join them together. Okay. Let's say we are also, instead of having customer name, we want to make it customer first name. So string customer first name. You don't want to do this. This one too is totally wrong. You try to run the program and you can see the red indicator because of the spaces in between. So we say that variable names are supposed to be written as what? One word. If the name spans more than a word. So you can see this name is more than a word. One word, another, and then another. Okay. So that is one thing you keep in mind. Number two, if the name spans more than a word and you are joining them together, we use something we call naming conventions. Now, naming conventions, they are simply styles for creating variables or styles we go by for, putting up or coming up with some variable names. And so we have three main. There are so many, but we have three main. We have the first one we call the what? The Pascal naming convention. We have the camel case naming convention. And then we have the what? Snake case naming. So these are the conventions we have. The Pascal naming, the camel case, and then what? The snake case. Now, this variable, customer first name, I will show you how it will be done in Pascal, camel, and then what? Snake case. It's very important to take note because this is what currently, or this is what is modern now. So, Pascal naming states that, all the words in your variable names, all of them should have, their initials should be uppercase. That means customer will be uppercase, the C will be upper, F, for the first name, it being the first letter, will be uppercase. And then in the name too. So strange customer first name is equal to Francis. So this is, if you see something like this, a variable name going like this format, then it means they are using the word Pascal naming convention. All the words that you are joining together, those individual words, they should have their initial to be uppercase. That is it. So customer last name is also going to be the same. Capital K, uppercase C, customer last name is equal to Abraham. If you are creating first name, F will be uppercase and then name, like that. So that is about the Pascal naming convention. So when you are joining variables together and you want to do it using the Pascal naming convention, this is how it's going to be done. Then we have the camel case naming convention. So with the camel case naming convention, it's very simple. The first word, okay, the first word will have its initial to be lowercase. Apart from that, the others are all going to have their initials to be, uppercase. So strange customer name, or let's make it customer first name. This is equal to Francis. And then strange customer last name is equal to Abraham. Strange first name is equal to Smith. So this is the camel case naming convention. You can see that the words that we are joining together, the first word is having their initial to be what? Lowercase. But apart from the first word, all the other words that we are joining together, they are going to have their initials to be what? Uppercase. This is all about the camel case naming convention. And with the camel case naming convention, it's mostly used. This is what is widely used. Languages like Java and then JavaScript, you can see them using this a lot. Okay. So this is about the camel case naming convention. And quickly, let me say this. You can see after I'm done with each statement, I put semicolon. Like I said, in programming, the same way in English, when we finish with our statement, we add semicolon, full stop. In programming, we need to add semicolon. If you don't add that, it's wrong. The program will not work. Okay. So this one, because of the spaces we left here, that's why we're having this error. So let me just take it off. And then let's look at the snake case. So for the snake case naming convention, it's very simple. You create, everything is supposed to be in lowercase. That's one thing you need to understand. Everything is supposed to be in lowercase. And aside that, you are also, you have to separate words with underscore. So meaning with the customer first name, everything is supposed to be lowercase, and then aside that, we separate words with underscore. So first name is equal to what? Francis. This is what we call the what? The snake case naming convention. Whenever you see, you mostly see this kind of convention, in Python. So Python uses this a lot. I think Python itself is a snake, so it's no wonder. So first name is equal to, let's just make it Smith like this. So when you see anything like this, then it's what? The naming convention. The customer or having the initials being uppercase throughout is Pascal. The initials being uppercase throughout with the exception of the first word is the camel case. And then separating words using underscores and all being in lowercase is what we call the snake case. The truth of the matter is we have so many other ones. Okay, just that at the moment these are the ones that are modern or the ones that are current. No need to teach you what is not current, so let's focus on these three. So that is what they are telling us here, that number one, it should be written together as one word if it spans more than a word. And then again, the naming convention like Pascal, Camel, and then the other one are also what? Acceptable. Then the last point says the only acceptable symbol for the name of variable is the underscore. So that means whenever you are creating your variable, symbols cannot be used. Okay, let me try and then see if there's an error in this program. You can see successfully there's no error. Let me add some symbol here and see. So we have the symbol here now. We try to wow, that's very uncomfortable now. Okay, so I don't know why this one is working, but let me try another one. So we have the @ here, and @ is not working. Okay, so from what we are seeing, I think C++ is currently allowing the $. Actually, $, I never knew it can be added. It can be accepted. Okay, but what we are looking at says that variable names cannot have a symbol in them. So that is it. @ is giving us an error. What about the hash? So we try to check, and the hash is also having an error. Okay, so that is about what we are looking at now. It can't have a symbol. Variable names can have a symbol, and underscore is the only accepted one that we can use. Okay, like what we used here. Moving from there, we have the don't. So this one is these are the do's. Then with the don't, it says variable names should not start with a number, but can have numbers within the name or at the end of the name. So if you do something like this, 3age is not accepted. What they are trying to say is, you can choose any name for your variable, but then just know that they can't start with a name, a number. So if I say 6 customer, you can see the colors even change. And if we try to run the program, we have an error. If I make it will not work. Okay, so you don't start your variable name with a number, but you can have a number within it. That is going to work. You can even add it at the end. That is also fine. It's going to work. But then the moment you start it with a number, that is chaos. It will not work. So that is what the first one is saying. The name should not contain a dot or any other character. So this one too is not done. It's not accepted. Make sure your name will not have something like this. And then lastly, it says variable names should not contain spaces. This one I think we've talked about. You can't add a space in between your variables like this. This is not accepted. Okay, so when it comes to naming variables, these are the approach or the rules we follow, and they are very, very important. You need to really keep this in mind. Other than that, it can prevent your code from executing. So that is it. And the good news is it's not only in C++, but in most more modern languages up there, like Java, C#, all of them, they go by the same principles. Okay, so that is about the rules regarding creating variables. Okay, let me talk about the constant, then we'll look at the other ones. So we are still looking into variables. When we say constant, it's very simple. Okay, when we say constant, they are very simple. So under normal circumstance, let me create constant. So let's say we have a variable int age is equal to 5. Okay, and then I will give the command to display the age on the screen. When I run the program, this is age, and we have age in between the cout, meaning display the content of this particular variable. You can see if I highlight this one too is highlighted. It's trying to tell you that it's making reference here. So if we run the program, you can see that we have 5 on the screen. That is good. That is correct. So I can come down here now and say age is equal to 20. So age is equal to 20 simply means I'm updating the value of what age to 20. So we build and run the program, and you can see I have 20 here like that. Okay, I have 20 here. So this is possible. Variable can't be created twice. Okay, so since I have created age and assigned a value to it, I can come down here and say int age again is equal to 20. When you do this, you are trying to say that age is the compiler should create another variable with the same name, which is not going to work. So variable names are unique throughout your program. They are unique. So you can't create two variables with the same name. Okay, so now we have updated it here. And when we say age is equal to 17, which one do you think will be the result? So we run, you can see 17 will be seen on the console screen. So this 17 is coming because age is updated. Now code are read from top to bottom. So when it gets here, the age was 5. When it came here, it was updated to 20. This one is the latest or the last update. So it's going to pick 17 as 8 what? As 8 value. But then the truth of the matter is, whenever you create any variable, you can perform update in the values like we are seeing here. But if the variable is declared to be constant, that means the value of that variable can never be changed. Okay, so let me just add some keyword const here, and then let's try to run the program. You can see now there's a red indicator here. Okay, this red indicator is simply telling you that this variable is not created to be final or is created to be constant. So 8 value is not meant to be updated like this. So now that these updates are not there, if we run the program, you can see that it's working successfully. Okay, so that is about the constant you are seeing here. They are just like variables, but their values do not change, or they can't be changed when given a value. So we can have a constant integer, constant float, constant boolean, constant, all the various data types. You just need to add the keyword const, and the moment the const keyword is applied, it's going to make the variable unchangeable. So that is about constant in programming. Okay, that's about constant in programming. Okay, so let's go back to our slide. Now the next thing we are looking at is arrays. So it says arrays are a collection of data of a fixed size and a specific data type. Array are a collection of data of a fixed size and a specific data type. But you know what? I think the time is almost spent. Let me just end it here. We will continue on arrays in the next lecture. Please, if you haven't subscribed, consider subscribing, and then try liking the video. Give us your comment. This is the only source of motivation we are getting. Thank you so much, and I'll see you in the next lecture. Bye bye.